Hello everybody and welcome back to Checks Notes, episode 17 of our video series in which we program an entire video game from scratch in the C programming language. And before we start, there really weren't very many comments, except I did get one interesting comment. Basically last time, in our game from last time, let me see if I can remember what I was doing here. Source. Right, so last time I was building that post build script that would basically just copy our assets into the correct place so that we could use the same relative path regardless of whether we were running in the debugger or outside of the debugger. But anyway, there was at one point while I was doing that, I wanted to copy this entire fully qualified path of this file. So what I did is I went to the security tab and I just selected this text right here and I hit Control C to copy the fully qualified path of that entire file. However, one viewer pointed out that you can actually hold down Shift and right click, and it gives you this cool little new copy as path option in the context menu, and then you simply just select that and voila, it copies the entire path to your clipboard. So that was just a little shortcut that I actually didn't know, so thank you viewer for teaching me something. So in our game, where we left off is, remember we were loading loading image files from disk and then drawing them to our back buffer, which is pretty cool if you ask me. Where you want to go from here is limited only by your imagination and what kind of game you want to play. From here, I think the next thing that we wanted to work on was animation, because as you see here, we just have one single image loaded. Well, technically we have 3 images loaded, right? We're only using one of them, and so it just looks like our dude is just sliding around, which is obviously not what we want. So that's why we need to start doing animation. But I think before we do animation, we should probably take a moment to think about the nature of how our hero, how our player is going to move in this game. And I remember going over this in the very first episode when I talked about what sort of game we were trying to make here. And I explained that we're not making a AAA game, we're making an old school retro 1980s or 1990s NES or SNES style game. And it's going to be more of like an RPG, like Final Fantasy or Dragon Warrior, for example. Like this. And find a good example of him running around. Essentially, it's grid-based movement, and every movement that your character makes, you're basically progressing from tile to tile. Each one of our tiles is 16 pixels. Our character is 16 pixels by 16 pixels, so he fits perfectly on a tile, and every step that he takes, he can basically walk from one tile over to the next tile. Contrasted with, take for example, Legend of Zelda, where you've got this sort of situation going on. And notice how in Legend of Zelda you have this freedom of movement where every pixel you can move to. Essentially, it's open, free movement basically. So that makes sense in a game like Zelda, because in a game like Zelda, you are fighting these real-time enemies. These enemies are on the screen moving with you, and they have the same exact amount of freedom of movement that you have. But in a game like Final Fantasy III or Dragon Warrior or something like that, um, you are not fighting these sort of enemies on the screen in real time like this. Instead, it's based on you encounter enemies through some sort of random number system where you just kind of like randomly stumble into enemy encounters, and then the game transforms into like this turn-based combat system, and you basically fight using your statistics mostly, like how much health you have, how strong you are, and it's more of like a Dungeons and Dragons style where you're basically you versus the monster. You're rolling dice against one another to see who wins. So that being said, the kind of movement that this type of game that we're looking at right here, that sort of movement, even though that's already what we have, I don't think that's what I'm going to stick with. I think I'm actually going to go with the other type of movement where when you press a direction key, you're going to basically move one tile at a time. And if you hold it down, you will keep moving in that direction, but internally in the source code, you're moving one tile at a time. And there's a couple reasons for that. I think it's going to be simpler for us to program. Number two is, considering that I think that the gameplay that we're going to create here is going to be more of a Final Fantasy style or of a Dragon Warrior style, where you encounter you have random enemy encounters, and then you go into more of a turn-based combat system. Therefore, this freedom of movement doesn't really offer anything. It doesn't offer anything new to the gameplay, or it doesn't offer anything important to the gameplay in a situation where you're not also having to compete against other monsters on the screen besides you. Hopefully what I just said makes sense. So that being said, that's how I'm going to do it. And you know what, I'm just going to start out by changing my player starting position to be multiples of 16, because essentially if our movement is going to be tile based and all the tiles are going to be 16 by 16, then every position that our player can land on, every position that he could stop on, is going to be a multiple of 32, right? So that being said, I think we should give our player, our hero, a couple more properties in addition to okay. I'm going to try this. I'm going to give him a movement remaining property. And the thing that basically the two pieces of data that I need to know are, one, how much movement does my player have left before he gets to his next stopping point. So for example, if I'm in one tile and then I hit the right arrow key or the right on the D-pad on my gamepad, when that happens, essentially my character is going to move one tile or 16 pixels to the right. So as soon as you hit that, movement remaining will go to 16, and it will steadily decrement until he gets to the center of the next tile, at which point the movement remaining will be 0. And I'm just sort of making this up as I go along, so this may or may not work long term. Just sort of experimenting. The other piece of data that I need to know is which direction am I moving, and I'm wondering I can either achieve this by putting some field in here about is my guy moving right, is he moving left, is he moving up, is he moving down, or maybe I could infer it based on the index of which sprite is loaded here. But I think that gets me into sort of a that might get me into sort of a chicken and egg scenario where I don't know which way to. I don't know which way my guy is moving until this index is set to tell me that he is like moving down, for example. But I don't know that he's moving down until this index is set to one of these values of facing down. So I could say, you know, if the index of this if the index inside this two-dimensional array here is like 0 to 3, 0 to 2, somewhere between 0 and 2 inclusive, then I know that my guy is facing down or moving down. I don't know about that though. Instead, I think I'm going just to do movement remaining, and I guess I'll just start like that with a direction, and I'll do I'll make some pound defines here. Okay. Left, and I think it's kind of dumb to have that on there. Okay, direction down, up, left, right, 0 through 3. Okay, and then when we go to Initialize Hero, since we know that the current index is, where is that set? Movement remaining. Did we ever? Oh, we actually never set this, did we? So in the beginning of the game, okay, maybe I do something like this. Current suit, current armor, and sprite index. I may change some of these names later. Recall that our entire goal here is our character is going to have 3 different appearances throughout the course of the game. So this is essentially going to be 0, 1, or 2, and it's going to correspond to that right there, 0, 1, or 2, suit 1, suit 2, etc. Okay, so I guess let me go ahead and just set some of these variables. Okay, let's set some of these variables like, okay, current armor equals suit 0, and direction equals down. Now, I feel like that might be a good idea, because we might be able to do arithmetic on these values later, where, for example, if I'm trying to come up with an index, I might be able to say direction down +1 or direction down +2, something to that effect. Facing down. I don't know. I'm trying to decide if this is redundant or not. But down, left, right. But I do know that I should at least have these in the same order. I need to be consistent with the order, like I have all the downs, and then I have all the lefts, and then I have all the rights, and then I have the up. Okay, all right, so and I suppose, since we know that our player is going to start in the stationary position, his movement remaining will go to 16. And now he is initialized as far as that goes. Now we go to render frame graphics. I could probably just go ahead and get rid of all this stuff. Don't need it anymore. And okay, so how do I make this correct for all situations? If I do direction plus that doesn't work for me. That does not work for me. I'm going to have to change that. Okay. This fine. Oh, okay. Plus sprite index. Okay. So if I do, so essentially we're doing player.direction plus it's fine. I don't need your help anyway, IntelliSense. Don't need your help anyway. Okay, so essentially if this is 0, gplayer.direction is 0, which is the same as down, and then my sprite index is also 0, which is the same as facing down 0, the result will be 0, which is exactly what we want. Now let's say, for example, we are moving upwards. This is going to change to no. How it's supposed to go is, let's say we're still going downwards, and then during the animation, while we walk from one frame or one tile down to the other, this is going to go from 0 to 1 and from 1 to 2, and that's going to simulate our footsteps. Okay, and then we will land, when we get to the next tile over, we're going to land back at 0. So should be awesome. Let's go to process player input, because that's where we actually move. And this is going to be interesting. This is going to turn into a lot of code, and it's going to be probably pretty messy. I want to go ahead and focus on moving downwards, because one thing at a time. Let's start with downwards. But you know what? I do like the idea of having it consistent. We've established this pattern of doing down, then left, then right, and then up. So let's do down, left, right, up in that same order. Now, I think I'm going to comment all of this out for right now. And I'm going to say, essentially, if movement remaining is okay, hang on. I messed up again. Let's go back to Initialize Hero. Movement remaining is going to actually start at 0, because we're stationary, right? So it was wrong of me to start with a movement remaining of 16. That would imply that we're already in motion, which we don't want. So now back to process player input. We'll go back down to here, and we are going to we're essentially not going to allow you to move the character while you're already in motion. For example, and this may be common sense, and maybe you already understand this, but just in case, I'll explain it real quick. Let's say you've got there's your screen, and there's your tiles, and hold on. Alright, so let's say your character is right here, and you want to move that direction. So once you press the right arrow key and begin your move into this next tile, we can't let you just suddenly start going up while you're in the middle of that motion, because if we did that, then you could potentially end up like between two tiles, and that would wreck everything, and we don't want that to happen. So essentially, while your movement, while there's still movement remaining, we're going to lock out the movement controls. So you can't move until your movement remaining falls back down to 0. So if it's not 0, or same thing, then then we're going to essentially rearm your movement remaining and set your gPlayer.direction equals direction down. Okay, I think let's keep going. Now, on the other hand, so we did, if there is no player movement remaining, then we process the down key. Otherwise, if there is movement remaining, then we should probably process that that movement, right? So if everywhere in here is where we're going to assume that there is player movement remaining. So we're going to do, and notice that I didn't actually move the player here. I simply set the variables that told us the nature of the player's movement, but I didn't actually move him. So all of the actual movement, and by that I'm talking about screen position Y and screen position X, changing those is going to take place here. It's going to take place only when there is movement remaining. So we're going to say if gPlayer.direction equals down, whoop, that didn't work, equals direction down, okay. Okay, then we will okay. Okay, if then we are going to do wow, my typing is really bad today. Player dot movement remaining minus minus and gPlayer dot screen Y plus plus, and I think that, let's see what that does. So remember, right now we only the down key is enabled, so we can't move left, right, and up right now. Yeah, it looks like we can't move at all. Did I? Oh, I messed up right here. Did an assignment instead of a comparison. Let's try again. Perfect. Now, notice I can't move left, up, or down, left, up, or right now, but I can move down. When I click the down key, I'm not holding it down, I'm just clicking it. My guy moves down a full 16 pixels, which is exactly what I want. Now I'm stuck because I can't move back up. So, but that's good though. Let me run it again. When I hold the key down, we get sort of a fluid. We get a fluid sort of movement there. So there's no problem holding the key down if you want to move down a whole bunch. But regardless of when you let the key go, your player will always stop on a tile, which is nice. Okay, that actually went pretty well. So let's implement the rest of the directions now. So we do down, left, right, up, down, left, then if X is greater than 0, okay, then what we're going to do is we're going to set that to 16, and we're going to set that to left. So Actually, I think we only want to process this for one thing at a time. Like if you're holding down the down arrow and the left arrow at the same time, I don't even want to know what's going to happen. I'm going to change this from an if to an else if to make sure that I can only fall into one of these situations per frame, like one of these situations at a time. I don't want to deal with the situation where I'm not going to try to like deal with diagonal movement. It's not going to happen. Okay, so else if G player dot direction equals direction left. Direction left, then, and you know what? I think instead of duplicating this line over and over again, oh, crud. Let's try that again. Instead of duplicating that line, movement remaining equals 16, over and over again, I can just type it once, because the only difference is in the setting of the direction. So this doesn't need to be said. Wait, up there, put it right there. All right, down, left, if right key is down, then we're going to do G player dot direction equals direction right. If up key is down, then we are going to player dot direction equals direction up. Okay. That looks correct. Now, let's go down here, set the rest of this stuff. And again, we know that every time we enter here, we're going to take one away from movement remaining, so we don't have to keep repeating that in every if statement. We can move it out to the next higher scope. Gplayer.movement remaining minus minus. Okay. And left is gplayer.screen position x minus minus. That's if gplayer.direction x plus plus, and finally direction up. Then we are going to do gplayer.screen y minus minus. That should do it. Let's check. Oh, I'm not touching the screen. I'm not touching anything. Oh no. Right, so crash the game. That is not what we wanted. So why did that happen? So we know that our player was moving constantly, right? As soon as we started the game, our player started moving. And why did that happen? As soon as the game started, our player started moving. So our movement remaining starts at 0. Oh, this is why. Okay. Our movement remaining starts at 0, so we skip all this stuff and go right into here. Then our movement remaining is decremented by 1, which is a unsigned 8-bit integer. So when you take 1 away, when you minus 1, an unsigned 8-bit integer, remember it's going to roll around to 255. So now movement remaining is 255. So that's obviously not going to work. So what we need to do is I think we should probably I guess we'll put another variable in here, though I feel like we shouldn't really have to. No, we shouldn't have to. I don't want to do it. I don't want, you shouldn't make more variables than you need to, right? So I'm going to try to reuse. I feel like we have all the data that we need to make this work. So what if instead I do if g player dot movement remaining is greater than 0. Why? What is the deal? Okay, let me make sure. Yeah, he starts with 0, which means on the first frame, if you think about this, our player, on the first frame, he starts with 0 movement. So he's going to enter this, and then he automatically gets 16 movement. Oh, I shouldn't give him movement even if no keys are down, right? Okay. So, unfortunately, that means this what I was trying to do before is wrong, where I was trying to not have redundant lines here, but I was wrong because I was saying I should give my player 16 units of movement, 16 pixels of movement, even if there were no keys down, which is obviously not it. So not what we want to do. So back to this, back to that, back to that. Now this one I believe can stay, because this one we're going to be taking movement away from the player on each frame regardless of whether any keys are down or not. So let's see what happens now. Okay, down, 16, over, left. Oh, that's cute. That's almost it. That's almost animation right there, isn't it? Oh, and then I move upwards and I disappear completely. Okay, so we'll have to work on that a little bit. Oh, we haven't loaded. We haven't loaded anything else except for the downward animation frames, so we shouldn't worry about those yet. We will fix that later. Okay, but that's correct. So, okay, here's how I feel about this. While we're moving, we need to do our animation. I guess I will do it after we have moved the player position on the screen, and we'll say I'm going to do a switch movement remaining here. And if you're not familiar, which I know everyone probably is, if you've watched up until episode 17, you probably know what a switch statement is, but just in case you don't, that's quite okay. Switch is just a fancy if-else block. It's just like, we're basically going to be checking different values of movement remaining, and we're going to take one course of action if it's this value, and we're going to take another course of action if it's that value, and then we're going to take a different course of action if it is nothing that we have specified, which is what this default case is for. But anyway, so let's say so I guess if I'm doing, let's go back to this. So let's say we're moving through time here, and this is, let's say, this is our 16 units of movement. This is a linear timeline of how long it takes us to move from one tile to the next. So if we were to split this into 4 pieces and pretend that all these pieces are exactly the same size, which they aren't, so let me erase over here just so this becomes clearer. Okay. 1, 2, 3, 4. So this is like, we basically want to have one sprite here, one sprite for this period of time, one sprite for this period of time, and then one sprite for that period of time. So I think what will happen is this first 25% will be something like walk 0, and this will be back to stand, and this will be walk 1, and then this will be stand. I think that will give us the animation that we want, and then when we get back to this, I don't think that's gonna look good, but we got to start somewhere. So let's start with that. So we'll say okay. In the case that movement remaining is 16. Oh, and by the way, I hate that Visual Studio indents it like this. Normally, Visual Studio is good about indenting your lines properly. When I hit the arrow key, notice how my cursor goes from here, and then it indents another 4 spaces, or 1 tab, or whatever. Then I type case 16, and then as soon as I hit that, it unindents it back over here. I don't know if that is the right way or if it's a bug, but it's not the way I like it. I think that cases should be indented. And why do I think that? Well, it's because I don't think that any brackets like this, I don't think that you should have 2 opening brackets right next to each other that are on the same column, right? I feel like opening brackets should always be your clue that, hey, this should be indented, because it's Anyway, I think it's a Visual Studio bug. If you think that it's actually proper, uh, uh, syntax or proper form, if you will, to type your switch case blocks like that, let me know, because I think you're wrong. I like them like that, even though Visual Studio doesn't. So I take extra effort to indent them. Anyway, so in the case that movement remaining is 16, that means we literally just started our journey from one tile to the next. So in that case, I'm going to change our sprite index to what am I going to change it to? What am I going to change it to? Yeah, I feel like this might need to get reworked. I don't feel like this is working out for me. Hang on a second. I am going to go pour a drink. I'll be right back. All right, where were we? Okay, so we're going to be cycling through these 3 frames. Down, walk 1, walk 2, 0, 1, 2. Okay. So I feel like let's just do... Let's change it to 1 there. And let that go for 4 frames. So when we get to this, switch statement again, 4 frames will have passed, at which point we should go back to our default standing pose, because remember, and I'll help you visualize this here. Let me go to users, I'll go to my source code, go to my assets, go to, here we are again, looking at here. Alright, so this is our, where's my arrow? This is our neutral standing position. And then this will be the next, he's going to take 1 step, and then he's going to go back to standing, and then he's going to take another step, and then he's going to go back to standing, right? So we are going to we'll work this out. Case 8. And then I don't think we can ever reach where it's 0, because if movement remaining were 0, oh yeah, we will. Because imagine if we get to this point right here and movement remaining is 1, then we will go to this block right here, decrement it, now it will be 0. So we will get in here with movement left of 0, at which point we know our movement is done, so we know that we should return to our neutral standing still position. So this is all messed up. Should probably be 0. This should be 1. And something, I don't know, it's still not right. Still not right, but it'll be okay. Let's go back to process or render frame graphics. Where are we drawing? Here's our hero. And we did already put, we have a direction plus an index. Do you think it'll work? Not unless I put the semicolon in here. Or colon right there. Okay, now keeping in mind that only the downward sprites have been loaded at this point, so let's see what it looks like. That actually looks really good. And then of course he disappears because we haven't loaded the sprites for the other directions yet. But look, when I go downwards, that looks pretty good. I don't know. I didn't think it was going to work out looking. I didn't think it was going to look like that, but it looked pretty good. So let's not mess with a good thing here. Let's go ahead and let's make sure. Yeah, he still moves by 16, even if I let up off of the arrow key or the S key. It works fine regardless of whether I click it once or hold it down. He's going to move 16 pixels. It's looking good. Let's load the rest of those sprites. Initialize Hero. Let's load the rest of these sprites. So hopefully when we get back, when we advance throughout the game, all of this code is still going to work without modification. We're just going to upgrade our current armor, and all of his sprites will change because the array index changed. Right, when we upgrade current armor from 0 to 1, all the other code is still going to work, and that's a beautiful thing. That is a beautiful thing. So now, this is tedious. We're back in Initialize Hero. We're going to load the rest of these sprites. And this is going to be, we got walk. Didn't I say we wanted to do this? I wanted to be consistent. So left, it goes down, left, right, up. So left, standing, goes here, facing left 0. Okay, and here I'm going to make sure that the file name is correct. Left standing, left walk 1, walk 2. I think that because I have my file names named inconsistently from what the variable names are named or the pound defines are named internally, that causes confusion, so I should probably correct that. I may correct it off camera because it's boring, but it needs to be done. Facing left 1. Okay. Left walk 2, facing left 2. All right, let's see what happens when we walk left now. That's what happens when we walk right, which is strange. That's definitely wrong. It's kind of funny, I mean, if we need like a dancing animation, we may keep this, but it doesn't look good while we're walking. Walking down looks fine. Walking left is ridiculous, and walking right is ridiculous. That's fine. So I think we're probably, let's just facing left, right, 0. Oh wait, nope. Right standing is going to go facing right 0, and this is going to be right walk 1. This is going to go facing right 1, and right walk 2 is going to go here, facing right 2. Yeah. Obviously, our animation didn't change because something is wrong with the way that we're calculating the indices, but I think we're still doing the right thing by loading the rest of these sprites. So we've loaded 3 downwards, 3 leftwards, 3 right, and now we're doing 3 up. Suit 0, upstanding. This is an upstanding citizen, upstanding. And he is going to go facing up 0, which is not what it's called. Upward. Okay. Suit 0, up, walk 1. Will be facing upwards 1, facing upwards 1, facing upward 1. And then this one will be suit 0, up, walk 2, facing upward 2. Okay, I've loaded all the sprites for the beginning suit of armor now, like the plain clothes suit of armor, which is great. They look pretty silly. Okay, so let's go back down to where we are calculating which sprite to display. Process player input. Okay. Direction down. Direction left, right, up. Right, up. And then movement remaining. Okay, sprite index will be sprite index 0, 1, 2, 0. Oh, and by the way, I'm not going to do it here, but pretty soon we're going to have to make some sort of assert function or macro. It'll help us debug situations where things have happened that should not have happened or that we didn't expect. But anyway, I don't want to get ahead of myself. We will do that in the upcoming episodes. Let me go back to render frame graphics. Okay, we know that that is always correct. Suit 0, that's always correct. Okay, direction. So if I'm going left, then I'm going to have a value of 1. And then my sprite index is going to, it's cycling between 0, 1, and 2. So, no. This is not right. It needs to be something like, I feel like I need to have multiplication in here somewhere. Like, what if I did direction times index? Because direction, if I'm facing down, would be 0. And then index will be 0, 1, and 2. So I think that would actually work out fine. What if I'm moving left? Direction will be 1. So 1 times 0. No, that's not going to work either. Okay. We can make this work. All we need to do is figure out this arithmetic right here. Direction left would be 1. So what if I did this? What if I, since right here in my pound defines, the left starts at 3. Right starts at 7. And up starts at 9. That doesn't feel right either. 9, 10, 11. Right. Okay. So now, if I'm moving left, then that's going to be 3, and index will be like 1 or 2. Let's go back to what is index? How do I calculate index again? Yeah, 0, 1, 0, 2. So I think, let's see what that looks like. Down looks fine. Left looks better. Still not perfect because I'm doing this weird sort of twist at the end of every frame. I don't know where that's coming from, but that's okay. We're making progress. And then left looks good. Left looks good. Up looks good. Right looks weird. We'll have to fix that. Down looks good. Yeah. I think this is all right. This is all right. Okay. That's animation, folks. We're going to have to fix where we're going to the right, but we will do that. Before I forget, though, there's a couple things I want to add here that we're not... I want to add some more stuff to our debug data, so I'm going to do that. Even though I plan on replacing this with our own text rendering pretty soon, which is probably what we'll do next. But for now, let me just do this. Unsigned long. I realize now that I never put the total frames rendered here, and this is probably 104, 13 pixels down. Let's see what it looks like now. A uint 64 is the same thing as an unsigned long. Or is it supposed to be long unsigned? I can never keep it right. I think it's backwards. The format specifier is like LLU, stands for long unsigned. It means I want to print a 64-bit number here. But the data type in your code is going to say unsigned long. The unsigned comes first. So I keep wanting to write it like that, but I think it's actually backwards, where it's supposed to be long unsigned in the format specifier. Whatever. We'll figure it out. Total frames. Seems to be working fine to me. And I wanted to do one other thing, which was screen position percent. Oh no, what have I done? I accidentally pasted. Pretty sure I undid it there. Okay, screen pose is going to be G player dot screen pose X and G player dot screen pose Y. And again, we move up by 13 pixels, so 117, not 1117. Let's see what it looks like. Okay, our screen pose is 32 by 32 right now. I'm missing a parenthesis. All right. Looking good. And everything is in multiples of 16, which is fantastic. So what I'm going to do is later on when we, he still looks funny when he's moving to the right, but anyway, later on when we come to writing our assert, our custom assert macro, that's definitely one place where I will use it is anytime, as soon as the player stops. If he does not stop on a multiple of 16, something is very wrong and I'm going to crash the game on purpose. But again, you know, getting ahead of myself. Anyway, so we got our animation in. This is pretty cool. Now, should I slow it down? I mean, does he look a little too like does he look a little too frenetic? A little too like he drank too much Red Bull? Should I slow it down? I don't know. I'll think about it. Let's see how much time we have. Okay, so I think that's about it for today. I think that is about an hour long. It took us to implement that animation. When we come back, we are going to have to fix our movement to the right is still kind of wonky. He wants to like turn up for one frame, up towards the upward direction for one frame for some odd reason. But left looks perfect, and down looks perfect, and upwards looks perfect, and I'm quite pleased with that. And we added a little bit of extra data to our debug output here. So win-win. Anyway, so that's all for today, and thank you as always for watching. If you have any comments, please leave the comments on the videos. I will address them in upcoming episodes. Even if you have questions about older episodes, that's okay. I will talk about your questions on any episode, doesn't matter. So just please don't be afraid to ask. And Also, don't forget that we have a GitHub repository to go along with this game. I keep the GitHub repository updated in step with these videos. So I think that's about it. That's not right either. He's not in, when he's going towards the right. He should be in a neutral stance right now, and he's not. He's in some sort of weird step. So anyway, we'll debug that next time. Anyway, thanks for watching. I will see you next time. Bye.